You are about to see those distinctive details of material, construction, and precision engineering that make a Steinway piano, whether a grand or a vertical, different from any other piano in the world. The difference that makes Steinway pianos so intuitively responsive, so incomparable in sound, they are chosen by 95% of the world's performing artists. I'm John Steinway, and welcome to a tour of our Long Island City, New York factory and the making of a Steinway. What better beginning than a portrait of our founder? This is Ii Steinway, my great-grandfather, who was an immigrant from Germany. He came to America in 1850 with his wife and 7 children, in that great wave following the Revolution of 1848. He started Steinway & Sons in New York with 3 of his sons in 1853. This photograph is a prized possession of the Steinway archives. It shows our first factory on Walker Street in New York. The whole family and staff are pictured. This is an early engraving of our Astoria, Long Island plant. In 1871, the company moved out of the bustle of the city to the location which is still our place of manufacture. After early success, the family was able to build a manufacturing plant in uptown New York, on the block front between 52nd and 53rd Streets on Park Avenue. This remained until 1910 as the final assembly plant. This is the plant we began to build in 1871, as it is today. The factory is larger and much more modern than it was in its early beginnings. But it's not ultra-modern like an auto plant. You don't make fine pianos with robots with welding fingers on production lines. This is an artist's version of the major parts that go into the making of a grand piano. There is a case that must hold everything together, a keyboard to be played, activating an action where the pressure of the player's fingers on the keys is transferred to the hammers that strike the strings. There is a rest plank, sometimes referred to as a tuning pin block, into which the tuning pins are driven. A soundboard carries the bridge through which pass the string vibrations. The soundboard amplifies and transmits these vibrations to augment sound waves. The cast iron frame, along with the assistance of the rim, supports about 20 tons of tension from the strings. And finally, we have the high tensile steel strings, different lengths, different sizes, and even a different number of strings in each set to make up the piano's 88 different notes. 85% of the piano is wood. There's a big difference in terms of quality. It is especially critical to use not only the right kinds of wood for their specific properties, but only the very top grades available. We inspect every piece of lumber that arrives at our factory to be certain that only the top grade of each wood used will be built into every Steinway piano. On arrival in our yard, the lumber is stacked into packages. Sticks across each layer allow for proper circulation of air in the drying process. The lumber is air-dried for up to 1 year and then kiln-dried down to about 4% moisture content to remove any tendencies for warping and cracking. The dried lumber is selected and marked for cutting. Here we see some maple, which will go into the pin block. You see that blemish on the board? The mark tells the sawyers to cut it out. Grains must be straight and clear in all Steinway pianos. Now our basic construction begins with the most basic and dramatic procedure of all, bending the rim. All grand pianos begin with the case. Let's see how Steinway builds those beautiful curves into its grand rims. Straight-grained hard rock maple is laminated and glued together in flat-grain sets. The number of laminations per set needed for the rim varies by the model, with the Model D Concert Grand having 18. But in all rims, the flat graining gives a 47% improvement of vibrational characteristics over cross-grained plywood-style sets. Here we see the crew preparing the maple strips for the rim. Steinway's unique system is to bend both an inner rim and an outer rim at the same time. This is the method that achieves ultimate strength and durability, and the quality of sound distinctive to Steinway. Others make them separately, and we think that compromises the integrity of this most basic structural component, which must, after all, sustain the strain of stringing, which can be as much as 45,373 pounds. I can't overemphasize how important it is to have the strongest possible rim. The sets of maple, about 20 feet long, are carried to the press and clamped into position. It takes a team of strong, skilled men. They work outward from the center, forming thin glue lines for superior adhesion. The press, an invention of C.F. Theodore Steinway, was patented in 1880. Here what are called the follower blocks are being forced into place. What makes this unique bending process possible is the fact that the 3/16-inch maple laminates are thin enough to begin with, and they're lubricated by the still wet glue. It is painstaking, it is difficult, but it shapes the best rim in the world. They work around from the center outwards, tightening the clamps. The presses, by the way, are lined with a brass sheet. A second brass sheet covers the outside of the package. The brass sheets not only protect the rare wood, but serve as electrodes for the heat-setting process. After the final pressure, the urea resin glue is set with high-frequency heat. This makes a solid, highly moisture-resistant rim. What results is a homogeneous foundation of unified inner and outer rim capable of standing the tremendous tensions of stringing. Each rim is removed from the press, chalk-dated, and stored upright in a conditioning room for several months, depending on size. In the 95-degree temperature and 45% relative humidity, the rims are cured. After the rims are removed from the conditioning room, they are cut to proper height by trimming both the top and bottom. When this trimming operation is completed, a soundboard mounting surface will be prepared on the inner rim to permit a solid mounting of the soundboard without restricting its vibrating action. This will maintain a permanent crown in the Steinway soundboard for maximum and permanent tonal quality and projection. We assemble the cross block. This is what seals the rim in an arch and holds the whole arch assembly together. Here is our first example of blind doweling. As strong as our glue is, we still reinforce it with the use of blind dowels. Next, the ends will be fitted to the rim and final pressure applied to seal up the assembly. Once the ends have been fitted together, as shown here, a couple of strong men will clamp the cross block in place. After the glue is set, you couldn't chop the joints apart. A glued and doweled assembly of case cornice and rest plank, also called the tuning pin block, are glued into the rim using 7 more dowels. Since our rest plank is like nobody else's, I'd like to dwell a bit on its distinctive features. The rest plank is made of 7 layers of maple, laminated and glued so that the grains cross at 45-degree angles. The sheets are glued together under tremendous pressure. Here we see how several rest planks are pressed at once with separating metal sheets. This model shows the 7 layers of wood at different angles. The pin is in place to show how it is grabbed down its entire length by the end grains of its maple laminates. This is our patented hexagrip construction. It is still ours alone, and the gripping power that this hexagrip construction provides gives every Steinway piano a tuning stability that is by far the strongest in the industry. The vertical uses the same hexagrip pin block, carefully fitted to the plate, as in the grand. In another part of the building, we veneer the grand tops. The core is double veneered on both sides in a cross-grained pattern. The core has grains running straight from front to back. This 5-ply construction makes a flat surface that stays flat. This is also true of the vertical top and sides. All Steinway flat case parts are made of 5-ply construction. The beveled edge around the grand top is not a yellow poplar core stained a walnut color. Much to the contrary, we apply a genuine walnut veneer matched from the same flitch. A nice tight shot of the matched bevel and top veneers. The bevel veneer is inserted into an undercutting to lock it down in position. We specialize in such manufacturing refinements. We are also particular, if not downright fussy, about our materials. All face veneers on each Steinway piano are selected from the same single tree. The piano has now moved to the case-making department. On the front ends of the rim, we shape our distinctively formed piano arms. Doweling is a part of good woodworking. Looking at the piano upside down, we can see the bracing on the underside glued to the rim. Then we drill holes and drive maple dowels through the brace into the rim to lock it in position. The same is done on the top side of the brace rim juncture to form a perfectly cross-locked joint. You'll notice there are no metal connectors to distort the sound or weaken the construction. This is the grand rim complete. We see the key bed, on which the action assembly is to be mounted, is already in place. It's made of a specially selected spruce, used for its tensile strength to assure that the key bed will remain true. Also making up this grand case assembly are other specially selected woods, such as the birch back bottom for anchoring the rear leg, and the birch nose bolt blocks attached to the braces in the treble area. Unseen here is the close-grained maple lyre top block installed. The lyre is the assembly on which the pedals are mounted. Steinway regularly delivers hand-carved pianos in two different styles. Old world craftsmen carve the case, legs, lyre, and desk. The model shown reveals the elegance of 18th century France during the era of Louis XV. Here's how we attach a leg to its top block so that it will last for many generations. The leg is veneered to match the case. The dowel is an integral part of the leg. We make a saw cut and put a wedge in. Then we glue those two together. The wedge hits the bottom of the dowel hole in the top block, and the wedge is driven into the saw cut, expanding the dowel. The sturdiness of this system permits the legs to bear the full weight of the piano, up to 1,000 pounds, and allows the piano to be moved without concern. The next important components are the soundboard and bridge. The soundboard is made of slow-grown Sitka spruce, a tall evergreen from the Northwest and Alaska. We use the highest criteria to select the finest grade available. It has wonderfully close grains, and the logs are quarter sawn so that the grain runs straight down the length of the board. Nothing else comes close to the acoustical qualities of this wood. The world's finest violin makers discovered this in the 18th century. To the native properties of the wood, we add an exclusive and distinctive feature, our famous diaphragmatic taper. This shows a model of the Steinway patented diaphragmatic soundboard. The tapered thickness runs from 8 millimeters in the center to 5 millimeters at the edges. It is fitted into the piano slightly crowned. This allows vibrations to travel freely along the grain to the center, moving more air, increasing the sound, and projecting it. Using a Steinway designed press and select California sugar pine strips, we glue the ribs onto the underside of the soundboard. The press is hollow, thus gluing in the crown of the soundboard permanently. The bridge, glued to the top of the soundboard, is made of vertical laminated maple, just like the grand rim. The bridge transmits vibrational energy from the strings to the soundboard. One important component made for us is the iron plate, cast from Bell quality iron in one piece from our exclusive patents. Here workmen are grinding off the casting markings and grinding the string mounting section to a precise level. After the casting is ground smooth, a heavy lacquer coating is baked on to protect the iron casting. The bronze finish is traditional. The plate determines the final position of the strings. The hitch pins shown here anchor the strings at the back of the piano. The A-graphs must be inserted into the forepart of the plate. They are studs through which the lower and middle register strings pass on their way to the tuning pins. Precision is essential, so we use string lines and a gauge for assuring that the A-graphs are perpendicular to the strings. Although 85% of a Steinway piano is handcrafted, we do use modern technology where appropriate. Here we trim the edge of the soundboard to fit the inner rim precisely. The soundboard, with its bridge and the cast iron frame, are now assembled inside the piano rim, or the belly of the piano, by a man called the belly man. It is an involved process to get the soundboard correctly placed and the bridge height precisely determined so that the pure Swedish steel strings we use will have the correct downward pressure or bearing on the bridge all across the scale. Extreme precision is required. The actual piano string must go from front to back over the bridge with just enough rise to exert up to 1,200 pounds of downward pressure. This is a view of the soundboard with bridge in place. Note the acoustic dowels. When the plate is finally bolted in, it rests on these so as not to interfere with the board's vibrations. The next step in making a piano is adding the strings. The traditional method of stringing by hand is combined with modern technology. The technique of overstringing the bass, a process perfected by Steinway, uses another innovation, the tuning pin placement machine. The stringer inserts a wire through the becket hole in the tuning pin. Then the machine turns the pin to put 3 perfect wire coils around it and drives the pin into the rest plank with even force at the precise angle. The center and upper strings, 3 for each note, are stopped off by the duplex at a precise relative length to the main string speaking length and vibrate in harmony. This duplex scale patent, devised by C.F. Theodor Steinway after much consultation with the 19th century German physicist Hermann von Helmholtz, delivers a richness of sound that is characteristically Steinway. This is a display model designed to show many exclusive features on the Steinway action. We use a lot of cloth, pure wool, felt, and buckskin to cushion the parts so that they do not rub against each other. The action itself must be noiseless. It should simply deliver energy to the hammer and let the string make the sound. The action assembly is mounted on a tubular metallic action frame, another Steinway distinctive patented feature. It consists of brass tubing stuffed with a hard maple dowel. The holes are drilled through the metal into the wood. The parts are mounted on the frame with wood screws. The low coefficient of expansion of metal provides the benefit of a stable frame that does not change with variations of temperature and humidity. The hammers for the action assembly are cut from a tapered sheet of felt, a blend of merino and other long staple wool. A set of hammers is placed in a press and the felt forced into shape for gluing to hammer moldings. All Steinway hammers are made in the Steinway factory and are drilled and compression wired for stability. This provides fuller, richer tone. After hammers are glued to the hammer shanks, the whole action assembly and the keyframe must be carefully put together and fitted into the instrument. Careful precision is important here because the position of the hammers is vital for their proper striking point on the strings. The precision of hammer placement is enhanced by heating the hammer shanks and making one of the many hand adjustments in the final regulating process of the piano's action. Measuring the depth of keys travel is another important phase of the regulating process. Special gauges are used to measure the proper depth of touch, 390 thousandths of an inch. If it goes too far down, we can add punchings around the pin to stop the key at a little higher position. This process must be done for all keys relative to one another. The pianist hitting an irregular keyboard would be rather deeply disturbed. Key depth travel is critical, and so is the adjustment of our patented one-piece phosphor bronze repetition spring. The adjuster uses a device to reach in, remove the spring, adjust as necessary by bending it, and put it back in. One of the main features of the grand action is those important little half-round bearings on which the keys balance. They're shaped so that the touch point where the key rests on the bearing moves backwards as the key is depressed. This allows for fast return to playing position, another Steinway patent. It's called the Steinway Accelerated Action. Our dampers, made from premium French wool, are glued to hard rock maple heads. The wool units are cut to fit single, 2-string, and 3-string unisons. If not dampened, a string will continue to vibrate. That should happen only when you want it to, and is controlled by the pedals. After rust-proof wires are attached to each damper head, they are ready for hanging by a master technician. Then a final adjustment matches the damper felts to the strings to stop the string vibration precisely and evenly. How does the master technician do it? He does it with mirrors. The job is hard because the adjuster has to reach way in underneath to get at those levers that actuate the dampers and bend the wires for alignment. When all adjustments have been made, the piano is moved to a soundproof room to meet an 88 rubber-fingered mechanical device. The fingers strike each key 10,000 times in a 45-minute period, in a wavy rotation, to break in the action over the entire scale. While the concert grand is being pounded on by that robot, I'd like to show you a view of the assembly of the back of a 46.5-inch Model 1098 upright. The machine in the picture was designed and built by Steinway. On verticals, the back must stand the same kind of stresses as the grand rim. At Steinway, we make certain it does. There is absolutely no difference in quality of design, materials, or craftsmanship between a Steinway vertical and a Steinway grand. Taking the bearing is as important on a vertical as a concert grand. The sides of this Model K52 upright have been glued to the back. While they're drying, the key bed is fitted and glued in place. The case fitter then fits the leg between the key bed and the toe of the vertical side. Mounted on acoustical doweling, the vertical plate is supported the same as in the grand. This model illustrates how the tenon joints of the post are glued into the mortised footpiece of a vertical back. This is what gives the vertical plate the same support as our grand rims do for the grand plates. And now for the voicing. One of the critical components producing the truly unique sound of a Steinway piano is the hammer. It is shown being filed and shaped here, one of the several steps in this voicing process. The voicer uses a piece of wood with sandpaper glued on it to remove the outer skin of felt from the pressing operation and to give the hammer a proper pear-shaped configuration. The resiliency of each hammer is crucial. Each is tried note by note and the action removed and the hammer subjected to a sticking with a 3-needle device to adjust its resiliency. The action is put back and tone tested again. This process is repeated until the entire keyboard is even in tone quality. In expert hands, the Steinway piano is brought to tonal perfection. Actually, each piano will have its own tonal flavor with various predominant qualities, such as brilliance, mellowness, warmth, roundness of tone, and the like. Since 1853, all Steinway pianos have been serially numbered, and they still are. This is the 300,000th Steinway piano. It was presented to the American people during Franklin D. Roosevelt's administration in 1938. It is still in use as the official White House piano. Its predecessor, our 100,000th piano, was similarly presented in Theodore Roosevelt's time in 1903. That is now in the Smithsonian Institution in Washington, D.C. Our 500,000th piano, finished in 1988, is another magnificent Model D. It commemorates our proud heritage of making the world's finest pianos. Steinway & Sons is the only manufacturer in the world that uses the same exacting standards of design and manufacture and the same hand craftsmanship in every single piano that we build, grand or vertical, for the concert stage or for the home. I think that now you have a more complete picture of our company and the way we build our pianos, and why a Steinway piano is different from any other piano in the world. You see, I learned the Steinway difference 50 years ago as a factory apprentice in the lumber yard, getting splinters in my hand. Thank you for watching.